Right. So yesterday we kind of covered a lot of different topics, and it was quite fast. So today we kind of recap and we repeat some of the things. So one of the things that we started using yesterday was modules, and Go 1.1.3 has more support for modules. So when you're working with Go needs to know where all the dependencies are, and there are two ways of working with it. One is called Go path, and one is called modules. They are incompatible with each other. So in a single project, you should not mix both. You can choose either using Go path or using modules. What's the difference? The difference is if you're using Go path, you're setting out an environmental variable called Go path, and that's where Go will install all your dependencies. So when you say Go get, it will kind of install it in that single place. So you have multiple projects, they will all point out to that one folder that you defined as Go path, and everything that you download and everything that you install will be in that one single place. And as you can imagine, if you have multiple projects which depend on different versions of a particular library, you get a bit of a problem because you kind of keep everything in a single place. And also, this place becomes really bloated because different projects will use different things, but they don't use all those things. So typically in some modern software development, what we do is we try to keep all the dependencies within the project itself. So there is a place where all the dependencies for a given project are kind of stored. So for example, Node.js uses that. So you have your project, and then you have all the dependencies in the Node modules subfolder where it keeps all the dependencies. So Go modules is kind of like that, but they still keep stuff in a central place, but it's more versioned and it's kind of easier to manage. So the dependencies are sort of managed per project, and there is a Go mod file. That's what we created. So if I go to our project, we created yesterday. So let's remove that one. So we have Go mod file, and that Go mod file currently doesn't have anything because we don't have any external dependencies. But if we had, all those dependencies would be specified in that folder. I mean in that file. So because I used IntelliJ for working with the code, I have some additional files. I have the IML and I have the .idea folder. Typically, we don't keep them in the version control. So if I say git status, it will complain that I have two files which are not currently in the version control, right? So how to get rid of this complaint? Yep. Git ignore, exactly. So we will create a file, git ignore, and we will tell it that chat IML, and yeah, I like folders first. So I don't want. So if I say git status now, it says, yeah, okay, I'm fine with those folder and this file because I know I should ignore it, but it complains about git ignore. So should I keep git ignore in Git or not? Yeah, there are two schools of thought, but I'm subscribing to the school of thought that you should keep git ignore inside the Git, so then all the developers kind of share the same ignore list, right? Some people say, yeah, but if I don't use IntelliJ IDEA, why should I be ignoring it? But you know, it's kind of a small cost of having single consistent thing that we should ignore. The other thing that we should ignore is if I build my server and now do status, that's what happened the first time I committed. I have also a server, I have the binary, right? So I probably should add my binary to git ignore as well. So now I will say add git ignore and push it. All right, so now I'm kind of sorted. It's clean. I can have a binary here, and it works. So if I didn't have, so now let's go back here. If I didn't have this Go module file, yeah, so let's move it to, call it Go backup mod. So now I don't have it, and if I say Go build server, it will not compile, right? It will say, well, oh my God, I don't know where your Go path is, and you're not using modules because you don't have Go mod file, so I cannot compile your project, right? Nothing changed in the project, it's just Go doesn't know how to handle all those dependencies. So when you're working on a new project, you have to make a decision. Am I going with Go path or Go modules? And your decision will always be, I'm going to go with modules. Unless there are some external force forcing you to use Go path, okay? And one of those external forces is it appears that Visual Studio Code forces you for its own dependencies for all the tools it uses for working with Go to use Go path. So for Visual Studio Code, for all the dependencies, you actually have to set up a Go path for Visual Studio Code to work well, okay? Then you do that. So you set up the Go path, you compile all the dependencies for Visual Studio Code plugin for Go, and it will kind of be within your IDE, but it's only for the IDE. For your own project, you will still use Go modules, okay? And the reason for that is that it's much, much easier to work with dependencies than with Go path. You're not confirming that? Yep. Yeah. So to work with Go modules, you have to do two things. So one thing is you need to have this Go mod file. And the Go mod file is, so I kind of have it here, but let's not do that. So currently I have a project without the Go mod file. So what I can do is I can say, generate a new Go mod file for my current projects in this folder, right? Or that doesn't work because I don't have the path. So let's try going from one. So go to mod init chat. Right. So you go outside of your project and then you kind of say initialize the modules for my chat project, right? So now if I go to chat and I cut Go stupid thing, it actually made it in the folder outside, so I have to move it from level up to here. And now if I cut it, so it says it basically tells me what the module name is and what is my Go dependency. It will use the Go dependency of the current Go version that you have. My Go version is 1.1.13, so it uses that one, and then it kind of names the project the way I kind of initialize it, right? So here you have also two choices. So one choice is you're only working on your project locally and you don't want to spread it like across the universe, okay? And then like a simple name like that, it's fine. And then you can reference it by this name. The alternative is that you want to move the project to GitHub or to some public Git, and you want to share it with other people. In which case, you would use a kind of a package name in Go, which follows the protocol, HTTP, or whatever the protocol is, the server, and then kind of a long URL with your package as the last component, so people can kind of easily download it, right? So that's effectively what the repo kind of path is. For the sake of this course, most of the time for our stuff, we will be not distributing it, so you can use simple names. But for things that we reference, we will be using those long dependency names, right? we will talk about it later. When we're using external libraries, usually you say import something something slash something slash something, and then that's the final path is the module, but the rest is like the URL, sort of like URL, to get how Go can download it from Git repository. So anyway, I have now this go.mod. I can remove my backup, and I can check if my go.mod. Oh yeah, I deleted the backup. So, but they were identical, right? So my backup and this thing were identical. So I can check it by doing git status, and I should have no difference between what I already had, right? And you do commit go mod into the repository. So you keep go mod in the repository, even though it's a generated file. The convention is that you always keep it, so then you save people who downloaded your project to regenerate the Go module every time they need to build it. Because as we've seen, if you don't have it, you cannot build it, right? Okay, so that's one thing. One thing is you need to have Go mod. The second thing is you need to say that your environmental variable, so let's see if I have it. I don't have it, but you should have an environmental variable called Go 111 module, and there are three options. You can have it on, you can have it off, or you can have it auto. If you have it auto, Go will pick Go path for projects which don't have Go module, and will pick modules for projects that you have Go mod. And the default one is auto. So if you don't have this variable defined, the default for Go 113 is auto. Okay. So if you want to have those duality, then you need auto, and you don't need to do anything. But if you want to force your Go to always use modules, then you can say on. I guess for us it's kind of safe to keep it auto because we will have Go mod for all our projects. Sometimes you may need to use Go path, like for example for Visual Studio Code. So I, for example, don't have this environmental variable setup, and in this case, Go will be treating it as if I had with this one, right? And then if you want to set it up, you put it in your .profile or however you're managing your environmental variables. You would say export Go 111 module, and then you will say auto, or you will say on, right? I had I had it to set to on before, and I had a project which was for my project I need to build a library, and the library was not using modules, and I had to actually turn it off because I couldn't build the library. So it kind of depends what you're doing. For most of our things, I think on should work, but if you get complaints like I did, like here, something like this, then you know, okay, it's something to do with my module management, that something is not quite right. You should have the Go root setup. Let's see if I have it. No, I didn't have that setup neither. So Go usually will work quite well with the, because Go knows where it is installed, so it sort of should work without the Go root setup. Your IDE, you may need to set it up for the IDE so it knows from where to use it. Okay, so bottom line is we're using Go mod. For Go mod, you technically don't need Go path setup. So for because I haven't been using Visual Studio Code, I don't have Go path setup myself actually at all. I'm just using modules. All right, so any questions about this? Is it kind of clearer? All right, so that's one thing. The second thing that we did yesterday, yeah, yep. Yeah. Right, so Init you only use when you don't have it. So you initialize it. And once you have it, you can always call, so I can always go say go mod tidy. And what tidy will do, it will browse all your source code, will check all your dependencies, and it will kind of tidy up your Go module dependency list. So it will sort it and it will check which ones are the direct things that you need and which ones are the secondary things that those things need. Okay? So for example, if you're this is a very simple project, so if I run it, nothing will happen. It's exactly the same file, right? You can always run this file, and you should occasionally run it in your project just to tidy up your dependencies, right? So what it does, it checks all your source code and checks what imports do you have. If you have an import which is not a standard library import, it will put it in this file. But so let's say for this project I'm using library A, okay? So it will say, okay, this project depends on library A. It will find it in the repository and it will add a line saying I'm depending on that one. And it's a direct dependency, right? But what if library A depend on library B and library C? Those are indirect dependencies, right? And it also needs to know which versions that this dependency is. So it will put, okay, there is library A, which is the direct dependency, and those two, which are second level dependencies with particular versions. And then if I'm depending on library C, which on library D, which also depends on library C, it will know that those are my primary ones and those are kind of secondary, so it will work out how many times something needs to be installed and so on. So tidy up basically does that. It kind of tidies up all this tree of dependencies. And you can call it multiple times. You can kind of call it when you don't have init as well. So instead, like if I will remove my go mod and I will call tidy. So it didn't. Like I did it yesterday and in 1.12 I think it worked. So now it says no, I will not create the module file for you. You have to create it yourself. So you have to go out. Like that's exactly what it recommends me doing, right? And call go init on that package that I have, right? So I will have to go out and call go mod init chat. And then I need to move the go mod to chat, and I have it back. I have no changes in my repo, and I can say go mod tidy now. So when mod tidy does something, it will tell you like what it did, like what new dependency it found, and so on. And it actually downloads the missing dependencies, right? So if I add in my source code import some JSON parser, for example, this one will find, oh yeah, this project depends on the parser. It will check if it already cached it. If it didn't, it will download it. And if I updated the version, it will remove the old version, install the new one, and so on and so forth. So that's the command you're using for sort of managing the dependencies for your Go project, right? And all the downloading and all the version control and version control of the dependencies happens kind of automatically. All right, any other questions? That was... You didn't have a question? All right. Yeah? I don't know. I think it's like, I think in the past it used to work with dot. I think I did it yesterday with 12 and it kind of said, so let me do this. Remember yesterday I did it and it actually put a dot here. So it like I had to change the name of the module like manually. It like whatever is using to whatever software is generating the Go mod, it needs to parse the project. So whether you're doing it from this level, it should be able to parse it, or whether you're doing it from level up the chain, should be able to do that. So I don't know actually. Yeah. But you need to tell it which folder it needs to use for this module, right? Yeah. No, but other questions? Okay, and So we will go back to Go in a moment. There is one more thing that I wanted to do today. I haven't tested it, so let's try it. I hope it will work. So it's for your project at the end of the course, we will require you to kind of work with issue tracker. And the issue tracker is kind of built in into GitLab. You have, issues here. We don't have many issues currently in the course. Let me just make it a little bit smaller. Is it still readable? Okay. So when you create a new issue, so let's create a new issue. So I will say chat, tidy up the code with linter. And okay, I'll assign it to myself. And labels. Yeah, Christopher asked me to have a new label called repo. So we will not. Did it pick it? Huh? Okay. Yeah, this one you don't have to use for this course. So this is like kind of more of a project management of how heavy that that issue is. So there are, again, two schools of thought. One school is saying that this number should be an abstract number. So you have some sort of an abstract measure of how heavy something is. So if you have, let's say, 10 issues to solve in your team, you assign particular weight to those issues. So then you can order them in terms of work that is required to fix them. So if one issue is 10 and the other one is 1, it means that the issue 10 is like 10 times harder than the issue 1, right? So it's an abstract number. And then you kind of deciding, like in your team, on a particular issue, how hard it is, right? And you have some sort of baseline, and then based on those numbers, you can calculate how much work can you do in a week on your project, so then you can plan your work, right? So if you have a backlog of 50 issues, you can calculate based on the kind of abstract number of how heavy they are and your average speed of how much work you could do per week, how long it's gonna take to finish the project, right? But for our project, you can use it, but you don't have to. The other school of thought is that you can just map it to hours, right? So you can say, okay, how long should that take, right? Fixing the linter, yeah, less than an hour, right? So you would say, okay, it's 1. You always round up to an hour, like nothing should be shorter than an hour. And you have some sort of an abstract, again, you have some sort of, because a full workday, let's say, is like 8 hours, and you should not have issues that are longer than 8 hours. So if you have something that's gonna take 2-3 days, you should decompose it to smaller things that gonna take at least at most a day, right? Otherwise, it's really hard to track issues. But for our sake, we don't have to use it. So if I create this issue, I'm not gonna use those. I will have. Yeah, I didn't put the label, but I will fix it later. Anyway, yeah, if I right, thanks. So we have it tidy now, and the issue number is number 3. Okay, so now if I go to my code and fix the linter, so if I go how you run the linter and go huh? Lint. Is it? No? I don't remember. Say it again. There is the, yeah, we usually use the full one. So let's say deprecate it. Okay, so there is a new one. So yeah, let's use the build one. No, come on. Yeah, so it's called Golang, but I need to install it. I don't have it installed. I don't think. No. All right, so there is a command called golint, and I can yes, it installed it. I have, yeah, so I have it installed. I just haven't put the path properly, so I have to do export path equals path, and I have to include my go path, which is this. Right, this export path. I have another shell, and that's why the other command didn't work for setting up the path. So if I go golint, now it will work. So projects, right. So I have it in my path, and I can call golint on the current project, and it has like 7 or so complaints. So it says I have a type client which is exported but should have a comment or should not be exported. So that's what we were discussing yesterday. So let's keep that in, and I will open another one. Chat. So we'll open utils. So I have the struct client, which is a public type, but I should have a comment or I should not export it, right? So I will. So I have 2 options to fix it. One is to make it to a small letter, but then I have to fix it everywhere, or add a comment, right? The more tidy way of fixing it would be to change it to small letter, but for that, using Vim is a little bit tedious. It's better to use IntelliJ. So I will quit that and fire up IntelliJ to change it. The idea is that once you do, I will just do one change to, yeah, let's just do quick one. So I will do that after the class, but for the sake of this, I will just say client represents the client, the data structure related to client connections. Okay, so I've added a comment for this one. So if I rerun it, I don't have the first complaint anymore. The line 9 is already fine. I have line 31 now to fix, right? So I have a client listen method, and L is capital L. So it's a public method, but doesn't have a comment, right? So now once I did the fix, I can say git at utils.go and git commit working on issue number 3, fixing public fixing exported things with comments. Okay, so I'm kind of putting a message which links to issue number 3. So if I commit it and if I push it, then it will nicely relink this to the issue tracker. And hopefully if I refresh this, yeah, so I'm already here, right? So it already refreshed it and put my commit, attached the commit to the issue. So you can have all your work kind of attached to the particular issue, the work that you're doing for that issue. And then also if you say things like closes or closed or fixed, it will actually close the issue, right? So the commit that you make in your command line will actually close the issue in the issue tracker automatically. And you can use it to kind of manage your work with your team. For the assignments, because those are individual, we don't care, but for the project, we will expect you to have this. We will expect you to have issues that have kind of a commits associated with the issues, and they are kind of closed by the issue, yeah? No, no, it's not a Go feature. It's a feature of Git plus issue tracker. So GitHub has this, GitLab has this, Bitbucket has it. Anything that you will use has this feature to link your issue tracker with your Git commits, so then you can manage that kind of nicely. And it's not Go specific, it works for any projects, like for C++, for whatever you're using. So it's a kind of a nice, convenient way of managing your teamwork, because then other people also can see, oh yeah, what did Mariusz do, right? So they can go to the particular commit and they can see what I've done, right? So they will see, oh yeah, I've added, right? So the diff says Mariusz has added the comment because the comment was not here and he did it, right? So that's kind of a nice, easy way for helping and managing the project. So that's that. What else? We have built this server part, and now if you say git pull, you will have the latest version of the code from the repository. And if you say go build server, you will build the server. And we know that we have the port option, so we can change the port, right? So we have one command line parameter, which is the port, and we can change the port. What I've added at home last night was the printout, right? So if you run the server with the default port, it kind of shows you where the server is running. And then if I run it with port 777, it kind of runs, it tells me, yeah, the port, we're running on a different port, right? So we have kind of the server running. How can we test it, that it actually works? Yeah? Say it again? Netcat, exactly. Who knows what Netcat is? Okay, so can you tell everybody what netcat is? Yeah, so what is cat? What's cat command? Yeah, that's right. So what cat does, it takes a file and then it feeds it into the standard output. Okay, so you can use cat to feed it to whatever you want. So you can, for example, pipe it into less, right? So cat now takes the content of this command or of this file, and then takes all the bytes, all the text, and pipes it through the pipe operator to another program, which in this case is less, right? So look what happens. Now less is showing me the content of the file, right? And unless I, for example, have a search capability, so I can jump to a particular thing. So if I say slash and start typing, I can jump somewhere, yeah? Huh? What's less? Yeah, so less is a program which takes which displays a content of a text file. It's a sort of a small line-based editor, and you can browse the file, right? So now if I want to find where my new chat room function is, I can press backslash and say new chat room, and it will kind of find me where that is in the file, and it will highlight it, and I can kind of jump and browse the file. And I also have cursors, so I can browse the file up and down, right? Down? Yeah. 72. Yeah, done. All right, so, and cat, so if I say cat utils, it like dumps the file into standard output, but you can use pipe to kind of do that. So ncat is kind of the same, but what it does, it takes whatever is in the standard input of your terminal and pipes it to a particular port on the network. So you can feed your commands into a particular port on the network, right? So to test this, what we can do is, let's see. So if I run the server on port 7777, and I have a new terminal, and let's decouple that. So I have my server running here. I have another terminal here, and if I say netcat to localhost 7777, now I have a connection between this terminal and this netcat into my server, and if I type something here, so if I say I'm typing here and press enter, then it will take this line and feed it into the pipe, into the TCP connection over to the port 777 on localhost. So what happened is the server got it and it redistributed it to all the clients, right? So let's start a new client, and I will do the same, localhost 7777, and I will type something here, and it appears on both places, right? So if I type something here, it is redistributed to both of the clients, right? So my IP address, how can I check what's my IP address? Huh? Say it again? IPA? I don't have an IP command. It's Mac. but it has if config. So if config, I can tell you that I am this one. So now what you can do is you can use netcat to connect to this host port 7777 and see if you can print something. Yeah, can you repeat that? If I run the server, or what do you mean by script? Yeah. That's right. So that's what I did here, right? So here I run the code, and it basically is running on my laptop. So it runs the server. It opened the port, and now everybody kind of can do stuff, right? Who knows my IP address and the port. The port is open. And actually it's accessible from internet. Yeah. So we have a kind of a basic kind of a chat server, and someone was kind of nicely trying the HTTP connection using curl, but you can kind of do the same with netcat, right? So what I can do is I can close this one and say netcat google.com port 80, right? And I can say get host google.com port 80, and I need to say empty line. And what Google sent me is the HTML document which says the page has moved. I cannot get google.com. I have to get www.google.com, right? So Google doesn't serve the home page from google.com. It serves it from www, right? So fair enough. So let's close that. And let's redo it. So if I do that again, and get means I'm getting the home page, right? And then host. And now I have the actual homepage of Google kind of cut it through my terminal standard input, right? So you can use netcat for playing with different connections, with different APIs, with kind of connecting to your mail server and talking to your mail server to read mail, for example, manually by specifying the SMTP commands, or POP3 to send mail, and so forth. Another one, so netcat is one, and another one is telnet. Most systems don't use telnet these days because telnet uses unencrypted passwords. So it used to be in the old days you could telnet to a host and log into it, like we do with SSH these days, right? So you can SSH to a Linux and kind of log in. And SSH uses encrypted passwords. Telnet is the same, but uses unencrypted plain text passwords. So if someone is observing the traffic, sniffing the traffic, they will see your password. So telnet is kind of telnet daemon is not run usually on the systems anymore, and telnet client is not installed. But if you install your telnet client on your Linux box or your Mac box, you can use telnet as well. So I can telnet to localhost 7777, and it's basically the same thing. So now if someone writes something, I kind of hear it. I have, again, the connection to this port, to this server. and it's shared. So the server works in such a way that it kind of redistributes whatever comes in to everybody, right? So what we could do is we could change the server a little bit as well, so it prints us the messages that that we have, right? So let's see. I managed to open it, and if I change the fonts, yeah, it's really slow. Fonts, yeah. So in our server code, we're making a reference to the run command. Please work. Where did we edit? We edited it up. Yeah, the run command adds the new. Yeah, so this one joins, this one listens, and then this one reads what data we have from the server. So what we can do is we can kind of add here that if someone sends us something and we're rebroadcasting it to all the clients, we can kind of print it on our own console as well, right? So if I edit kind of a line here, printing print the data, then I would kind of see all those messages kind of here as well. Currently the server is like silent, it kind of gets the messages, but then it rebroadcasts them and we don't see them. All right, any questions about this? So I will not talk more about the server and we will not do the clients today. We will do that in a while. What we will do, I had a request for going over the problems that we have. So if I go to the problems, hello world, okay, who doesn't know how to do hello world in Go? Everybody knows? One person doesn't know? You don't know? All right, so let's start with hello world then. So can you write hello world and do a pull request to the repo? So create a folder called hello, put inside a hello world program, and make a pull request to the repo. Who does it first will kind of get a brownie point. All right, so while the hello world people are on it, what was the next one? Okay, so the second one was to decompose the hello world function to be not in the main, but to have main package different. That's what we did with the chat client. So in the chat client, we have utils in the top level, and we have the main function which calls the chat from the command package, right? You remember this? We've done it yesterday. So we have util, where is it? We have the util file, which is our file, which will have one function, which prints hello world, but you will not have main function here. And then you will have another package with the main, which calls this one. So that's what we did yesterday, right? So that is the second task. So you can do hello2 and do this one in the hello2 folder, okay? I will see if someone did the pull request. Project. No pull request yet?
You go into. Oh god.
So, right. So you have to clone. You have to fork the repo, right? You don't have to. You need a branch. That's right. Yeah. So you can clone the repo, make your local branch. In the branch, you will put the new files, and then push the branch into the server, and then once that happens, you should have a button saying pull request.
You have merge request to the left and the right one.
Yeah. This one here.
Yeah, it's like the project and the branch and that.
Yeah, that's right. So but because we have no branches yet, we kind of can't do that. But you will be able to do that once you push the branch. How do you know how to make a branch? In Git? So yeah, you do git clone, and then just to make sure that you're up to date with everything, you do git pull, right? So now somebody actually pushed a new branch, which is great. What you do is you say git and the name of the branch, right? So yeah, so you can say git branch, then the name of the branch, and you can also say what name it should have when you push it to the repository. So you can say -u also, but if when you're pushing it, will kind of assume it's the same name. So yeah, you only need to do git branch name, my local or hello world. And then when you push, you will push with the branch, and then you kind of do the merge request. Will I get the notification? I should. Yes, I got the merge request. Great. So Carl did it. Fantastic. I will review it. So I will have a look how it looks like. Yeah. Perfect. So we have a the files always start with the package. So you have to have a package. If it's a main, like if you only have one file, it will be main. But in this case, we have a package hello, and then we have a function which prints hello world to the console, and the function is using printf public function from the module called format fmt. A lot of packages in Go are kind of short acronyms. So we importing a format because we only importing one. You technically could write it here without the brackets, but if you have more than one, that's the kind of a way to organize your formats. You have comments, and then you have a single function. So functions in Go start with func, and then there is a function name, parameter list, return type. Because we don't take any parameters, we don't return anything, it's pretty straightforward. So it looks perfect, approved. So Carl gets brownie points. we have more. Yep, so that's sorted. What was the next one? So the next one was to split it. So Carl almost there was a main file which will call this one. The next one was write a function that takes 0 arguments and creates a new function, right? So let me just talk a little bit about it. So it's super slow. Okay, I'm a little bit impatient, so I type. Well, let's do this one. So I have a main package, and now the task is, let me read it again. So write a function that takes 0 arguments and returns a function that takes 2 arguments of type int and returns a sum of those parameters. So those who already know how to do it in Go, can you please do it in C++ and do a pull request to the repo? So make a folder called fun2 and do that in C++. I will do it in Go here. So we need a function which creates another function. So this function takes no arguments, so it's no arguments here, and it creates a function which takes 2 arguments, and those arguments are ints. And the function that I will return returns int as well, right? So I have now a function f that takes no arguments, which returns a function which takes 2 arguments and returns a single argument. And I need to return it, right? So I have to return a function that takes 2 integers and returns an integer and returns a plus b. So that's how it looks like in Go. I have a single function which takes no arguments and returns a function. So now in my main, what I can do is I can say I have a, which is the result of calling f. And now I can call a with 2 parameters, 2 and 3. And a will return me a sum of 2 and 3, right? Is it clear? Does it make sense? So I can say format print. So if I have 5, right? It prints 5, it builds, doesn't complain about anything. It's an example of a function which returns another function. If you were to write this in C++, so Carl will or someone will do that in C++. Do we have? Yeah. Question? Yeah. you can do that. So what you can do is you can call f and then call parameters on top of that, right? It will work same way, yeah. So now I'm executing f, it gives me a function, and then on that function I'm actually calling it, and so let's yes. Same result, same effect. All right, so the second task was to do the same, but to do the same here. So how can we do that here to achieve, whoops. Yeah, so let's say we don't have this block. We want to achieve the same but inline. So here we want to have an anonymous function which returns a function which we can call. How can we do that? Well, it's exactly the same. So you say, I have a function which takes two arguments and returns an integer, which is this, and then I call it, right? So so this function now doesn't have a name. If a function doesn't have a name, it's called anonymous. This function had a name. The name of that function was f, and the name of the other function which we used here was a. But this one doesn't have a name, and I'm calling it. So I now have a function with no name, and I'm calling it here, right? So let's make sure that it's true. It's true. We run it, it's 5, right? So it works. So it's a concise way of defining a function, kind of. Sometimes you need to pass a function to something. So then you can just do this. You can kind of write an anonymous function. They are in C++ as well, right? So in C++ you can write anonymous functions too and use them kind of in the same fashion. The syntax is a little bit different. So because Go is using names first, types after, instead of types first and names after, it's kind of more consistent. So in Go, the reading of this is always names and then types, parameters, types, and so on. In C++, it's a little bit kind of a mixture because you're saying int b and int a, and the return type sometimes is at the end, sometimes at the beginning. It's a little bit kind of a more syntactically difficult to parse it, like mentally, maybe. And in Go, they try to kind of simplify it, and that's why they use this notation of names first and type after, because it's the same for this, right? So I have a function which returns a function. In C++, it will be kind of that the fact that f returns a function will be kind of in front of it, right? All right. Next one. Any questions about this one? Yeah? Quite a lot, actually. So once we start working with callbacks and once we start working with handlers for particular things that happen in your web server, you will realize that you need a lot of functions everywhere. And then often what you want is you want kind of a generator of particular function based on something that happened. And then you will be generating functions and passing them down the stack, right? So it's kind of a way of encapsulating your computations. So in object-oriented programming, what you do, you often don't use kind of a composition of functions. What you do, you create a class with methods, and then you compose them in another method, right? But here, because as we were discussing yesterday, Go has a little bit more functional kind of a feel. What you do, you kind of compose your computation based on functions, and functions which call other functions or generate other functions. And this kind of mechanism is often used. So you will see later in the course. Any other questions? Right, so let's move to the next one. The point of this exercise was to sort of get you accustomed with like how you compose the types, how you use with the type system. All right, so factorial. So factorial loop and factorial recursion. Can you try to do that? Same story. So if you write one, make a branch, make a pull request, a merge request, and I will put it into the repo. I wrote it last year, but I don't need to write it. I know how to do it. You do it. So try to write it. If you get stuck, ask question like how to do something. You know Fibonacci numbers? Yeah, so Fibonacci numbers is, so if I say, let's say I will have a function called fib, and I will tell it print me 5 first Fibonacci numbers. So the numbers will be 0, 1, 1, 2, 3. So the first two numbers is 0 and 1, and then each consecutive number is the sum of the previous two numbers, right? So what will be the next number? 5. What will be the next one? Exactly. So this is the Fibonacci sequence. 34, is it? And so on. So if I call it with 5, it should print me the first 5. If I say it print me the first 50, it will print me 50. Okay. So prints the first n Fibonacci numbers. So while people are doing it, which one is easier to write? Is it easier to write the recursive version or the loop version? Yeah? Yeah? So we have divided opinions. Who thinks writing a loop is easier? 1, 2, 3, 4, 5, 6, 7. Who thinks writing recursive version is easier? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, marginally. I think recursive is easier. For this case, it's so simple that it's actually like almost identical, and that's what the voting says. But in general, if I tell you to do a bit more complicated things, like in terms of computing, usually the recursive step, like decomposing it into the kind of doing something and calling itself, tends to be a little bit simpler. Which one is faster to run? Loop, yeah. Loop is faster. Which one will use more memory? Yeah, recursive version will use more memory, right? So if you say, okay, recursion is marginally easier to write, maybe not, there are mixed opinions, and it's slower and it consumes more memory, what's the advantages of using recursion? Yeah, so unfortunately, if it makes it much easier to write something in recursion, then you may start with it, and then if it tends to be too slow, you have to rewrite in the loops. It would be nice if we can write kind of in an easy way using recursion, and the compiler can kind of unfold it and turn it into loops. And it does happen. So there is something called tail recursion. So tail recursion is if you wrote something and the final step is you calling it yourself, right? And you don't keeping any state in this call. You're just calling yourself. So this one is called tail recursion, and it's kind of really easy automatically to turn into a loop. But if you keep the state, or if you're calling yourself somewhere else, not in the last step, then it's harder to turn it into a loop and all automatically, and it's slower and consumes more memory. So it's kind of less efficient. So when we're writing recursive functions, we usually try to make it tail recursive. So that's also an interesting thing that .NET, the virtual machine which runs C# and those Microsoft languages, has a optimization for tail recursion built into the VM. So functional languages which often use tail recursion are kind of efficient on .NET platform, whereas Java, the JVM virtual machine, doesn't have it. So the tail recursion is kind of slow and bloaty. All right. You can try rewrite it in C++ as well as a kind of an exercise. So factorial. Okay, so who watched the videos from last year? Yeah, good. You all should watch it. I kind of repeat it again, but you should watch it. I will not kind of do that again this time. I covered the object-oriented programming quite extensively, how you use the structs and how you're passing the parameters by value and by pointer, and how you're using interfaces and how you're using kind of struct methods. So you have to watch those videos. So we also covered a little bit of the concurrency in those videos. So watch them, and then if you have questions, we can go over the things that you don't get. So what we will do as a final step is we will do this one. So we have kind of a very simple client server which uses the TCP protocol. What other protocols do you know apart from TCP? Yep. UDP, what's the difference? That's right. So what we technically say is that TCP is a connection-based protocol, right? So TCP establishes a connection between two nodes in the network, and then the packets are kind of transmitted reliably between the nodes. So if the packet doesn't arrive, that server kind of complains, and then it's resent. And the packets always arrive in sequence, right? So we have a connection, and whatever I send, I reliably use the knowledge that you will get it. And also, if I'm sending two things, I know the first things I send will get to you first, and the second will get to you second, right? UDP is connectionless oriented protocol, which means there is no connection, which means if I send a packet, it may arrive or not, and if I send two packets, they may arrive in sequence or they may arrive out of sequence. So my second packet may arrive first, and my first packet may arrive second, right? So
Packets may still arrive out of order as well, but the server will put them in order.
That's right. So as far as the client is concerned, it will reorder them to make it kind of as if they arrived in order, right? So when I'm sending files, can I send files using UDP? Let's say I'm sending a Word document. A large Word document will be split into packets, and I'm sending it over UDP. Can I do that? Yeah? Yep, so probably not, because if I have my document on the other end and there is one packet missing, it will be kind of broken, right? So I will not have the same file on the source and on the destination, right? So where do we use UDP usually? Yep, for streaming, exactly. So the advantage of UDP that it's much faster than TCP. So for streaming audio, it's okay. So when I'm getting packets with my voice on the other end, and one of the packets is missing, okay, there will be a small degradation of quality for a brief moment, hopefully, but then it kind of continues. And if I'm missing one packet, it's okay. But if I'm sending binary files and I'm missing one packet, I'm screwed, right? So I cannot use UDP for binary files. All right, so web servers. Do web servers use UDP or TCP? Yep, TCP, because if I'm sending an HTML document, I have to get the whole thing, right? So the web server will kind of be similar to what our chat server is. It will open a port. What is the default port for HTTP? 80. What's the second default port? Huh? Yeah, so 443 is for TLS, for HTTPS, and then 8080 is another open HTTP protocol, which is typically used. And then we typically use 8081, 8082 if we need more kind of a standard ports. But we can use whatever. So for example, if you implementing something in Node.js, they usually use port 3000 as the default one, right? So all the ports up to 1000 are kind of protected. So the first 1000 ports has a special meaning because those are kind of a privileged ports. So normal users suppose not to open ports in the range up to 1000. So that's why port 80 is privileged. Port 22, what's port 22 responsible for? Yeah. SSH, what's the SMTP default port? 25. So there are some kind of ports which we use for common protocols which are privileged and only super user can open them, right? But ports above 1000, any user can open. So port 3000 or 8000, whatever, it's kind of unprivileged. So what we want to do here is we want to write a very simple server that handles a request to hello. So then we can use a netcat to ask, and it will return hello world, right? So how would you do that? So let's go. So we already have, we sort of have the snippet for the accepting, but this one accepts any connection, not specifically HTTP, right? So that's how we connect. This is how we do get requests and post requests using the HTTP package, which is all nice. So here we have a description saying there is a call listen and serve, which starts HTTP server for us. And then you have a handler which will handle requests to a particular URL. Whoops, right? So you register a handler, which is a function which will be called when the URL is kind of requested out of our server, right? So then once you register that, then you do this, right? So this is like back to your question, where are we gonna generate functions which return functions and so on? So here you can see that I either register the full, I have a function which I have to register it with a particular path, or I'm using a call which will generate a function and then register it with a particular block, right? So in this case, I'm kind of putting a function parameter here. So this this call requires a function, inline function, to register it with the particular handler, right? So if I copy that, so let's delete this. So we need hello, and we need a function which prints hello world. This one, I don't need the path. Can I run it on 480? Not as a normal user, right? So as a normal user, I can run it on 8080. Because port 80 is privileged. Okay, let's check. Let's check if that will work. So how can I test it? I could use ncat, but it's a bit tedious. How can I simpler test it? I can go to my browser and say localhost port 8080. Hello. Well, look at that. It prints hello world. So it kind of worked. What will happen if I say hello 3? Whoa, look, it actually says page not found. Great, right? So Go has kind of a built-in web server which will handle those particular URLs that you specify and handles everything else with a page not found for you, right? So I wrote like 2 lines of code, 3 lines of code, and I have a simple web server which responds to my /hello requests by printing hello world down into the network pipe, right? And it listens on this particular port. So very simple. The net HTTP package is quite powerful. To write most of the assignments in this course, you don't need anything else. You can just use net.htp and write your handlers and write your kind of functionality, your APIs using that. So if you want to serve JSON or if you want to serve whatever, it follows the same basic structure. So the next step was to change it in such a way that you can call it with a parameter. So I can call it with hello. Oops, sorry. Yeah, it's too small. I just type it here. So I can call my browser with HTTP localhost, in my case 8080, and then hello, and then I put a name. So if I say Mariusz, then it will print hello Mariusz. If I say Joe, it will say hello Joe, right? How would you do that? So one hint I already show you. You put a wildcard here. So you say this handler should handle anything that starts with /hello/ and use the rest, whatever it is. Doesn't matter what it is. So now that will work. So if I compile it and rerun it, yeah, I kind of should not do that. So now if I run my client and I put hello, it says, okay, I don't know how to handle hello because it only knows how to handle hello with something after it. So if I say hello Mariusz, it still doesn't work. Yep. I think you're right. So let's rebuild it. Rerun it. So it works with Mariusz, it works with just /, and it should work without / as well. But if I say hello 3, it should not work. That's great. So now it works with the extra things here. The thing is you just need to parse the path of how I called you and then extract the final element to use it as a name. So to say hello world and then put the name here, right? So that requires extra 2 lines of code, which is parsing of the path which we had, which is here, right? Oops. So the request.url will give you the actual URL object, and the path is the whole path of what I was called with. And then the last part of the path is the name that you should say hello, right? So if I, let's do that final thing. So if I take this, and if I say hello, so as a homework, try how would you parse it? Try to find a parser which will take this string and get the final part of it, right? So yeah, that's it for today. Do you have any questions? I can stay for a bit. All right, thank you. Hey, just give me a second.